Hubble really has changed the way we look at our universe. It's been extraordinary.
From the Museum of Science in Boston, this is Pulsar, a podcast where we blast off for answers to the deepest questions we've ever gotten from our visitors. I'm your host, Eric, and this month marks the 30th anniversary of the rescue mission to the Hubble Space Telescope. You may be familiar with some of the most famous images and discoveries from Hubble, but you may not know that when it launched in 1990, a tiny flaw in the manufacturing of its main mirror rendered the Space Telescope much less effective than it was designed to be. After a plan was made for a fix and corrective instruments were built, 7 astronauts got the call to ride the Space Shuttle Endeavour into orbit and breathe new life into the Hubble Space Telescope. My guest today is one of those astronauts, Dr. Jeff Hoffman. He's currently a professor of aerospace engineering just down the river at the Massachusetts Institute of Technology, and he is a veteran of 5 space shuttle flights. Only 9 people have left Earth behind on more occasions than Dr. Hoffman. On one of his recent visits to the Museum of Science, he shared the results of one of his more recent projects, an experiment on the Mars rover Perseverance, with our museum visitors, and he sat down with me to answer the question of just how the Hubble was fixed. So Dr. Hoffman, to start, at the time, what was it like to have the Hubble Space Telescope not work after its launch and need rescuing? Can you talk about the feeling in the science community and overall?
The Hubble Space Telescope was put in orbit in the spring of 1990. And there was tremendous excitement in the public. It was very well publicized. People were really looking forward to, learning the new secrets of the universe. And so when it turned out that it couldn't focus properly, people who didn't live through that era, it's hard to imagine what a disaster it was for NASA, but also for the astronomy community. And that was around the time when NASA was trying to convince Congress to start funding for what would eventually become the International Space Station. And as you can imagine, Congress was not very happy with NASA. And, the message was, do something about Hubble.
So it became a very high priority to find out if the telescope could be fixed.
There were lots of teams, optical engineers, mechanical engineers, astronomers, astronauts. First, we had to figure out what went wrong, and finally we did. It had to do with the misplacement of the device which actually measured the shape of the mirror when they were making it, so that the mirror was slightly too flat, but it was still perfectly smooth. And it was spherical aberration, which can be corrected with supplementary optics. So then the next year was spent figuring out how are we going to do that. And for each of the instruments, you have to put in 2 little mirrors in just the right place to block the out of focus light, reflected off another mirror, slightly curved, and back into the instrument. Very delicate. Plus, there were many other things that had gone wrong with Hubble. The solar panels weren't working right. There were tape recorders which weren't. There was a bad fuse and so on. About a dozen different things. And when they actually analyzed it, it was going to take 5 spacewalks in one mission, which NASA had never done. And it was so supercritical that they said only people who had previously done spacewalks and obviously had gotten good marks for how they worked would be eligible to do the spacewalks for Hubble.
And you did have that experience. Can you talk about your spacewalks on previous missions?
On my very first space flight, which was back in April of 1985, originally it was going to be a short 4-day. We launched 2 satellites on day 1 and day 2, do a few experiments on day 3, and come home. Well, the second satellite didn't turn on, and much to everyone's amazement, NASA decided that they had never done an unplanned spacewalk before, but 2 people were always trained to use a spacesuit for every shuttle flight, and I was one of them. And they told us, yeah, we think you can go out and help fix the satellite. And so I did NASA's first unplanned contingency, they call it, spacewalk. I had my union card for doing spacewalks, so and I guess I got good marks. And I always felt comfortable in a suit, which is not true about everybody. But in any case, yeah, I got the word that I was selected, and then it was a whirlwind year of training.
Yeah, I imagine the training would be very intense for this specific important mission with this many spacewalks. Can you talk about what that training involved?
The training for the Hubble Space Telescope rescue mission was extraordinary. anything that anybody could think of to reduce the risk of failure. For many flights, you might not be able to get it done, but because it was Hubble, I mean, I would be in the water tank one day and, I would say, if this wrench had a 20-degree bend in it instead of a 10-degree bend, I could probably get it on a little bit easier. Most of the time they'd say, well, deal with it. But no, this was Hubble. The next week we come into the water tank and there's the 20-degree bend. And I mean, maybe the most important thing, weight and balance of the shuttle are very important. They have to do a lot of calculations before the flight. And usually by about 6 months, all that has been calculated. The original plan was every time we were going to do a spacewalk, we would go out of the airlock. We have a tool carrier on our spacesuits. We'd go to the rear part of the shuttle where they had the toolbox. We'd take the tools out, put them in our tool carrier, and then go into our work. And at the end of the day, we'd go back to the toolbox. But we were spending like a half hour going back and forth to the toolbox, changing out our tools. And the critical thing for the Hubble mission was, EVA time by the astronauts, because that's where we were going to do the useful work. And so we suggested, if we could have all those tools inside the airlock, we'd save a half hour every day. And most of the time they say, sorry, we've done the weight and balance, it's too late. But no, we got the tools inside, and it made a big difference. The very first day, we replaced some of the gyroscopes, but we couldn't get the doors closed easily, and it took about an hour to figure out how to do it. We finally did get it done, but I was out over 8 hours. My batteries were starting to fall off. If we hadn't had that extra half hour, we wouldn't have gotten the job done. So it really did make a difference. And so it was extraordinary working on and training that flight. I mean, we spent about 400 hours underwater, and it was intense. Back then, they didn't have the big water tank at the Johnson Space Center. We did our training at the Marshall Space Flight Center in Alabama. But it was great because it was 100% concentrated on what we were doing, and it really paid off.
Now, some people might think that the Hubble Space Telescope needed fixing and NASA called you and a couple of other astronauts and you ran this rescue mission. But as with any space flight, there were many people of all backgrounds involved in making this rescue a success. Can you talk about how it was a team effort involving a whole lot of people?
Whenever you have a well-publicized space mission, of course, the public sees the astronauts. What I wish were more easy to share was the idea that the astronauts are sort of on top of a huge pyramid of people who make these missions possible. I mean, there were thousands of people, ultimately, if you count all the people who worked on the Hubble rescue mission back in '93, from the people who get the shuttles ready to go, the people who work on the spacesuits, the engineers who designed the experiments, I mean, on and on and on. People saw us on television, and that's fine because, ultimately we did the work that fixed it, but that work would have been absolutely impossible without incredible efforts by thousands of people. So anyone who's listening to this, I hope will realize, and that's true for all space missions. The same thing when you see a rover operating on Mars and these spectacular pictures of helicopters flying on Mars, and thousands of people involved to make all those things work. So it's a big team effort, spaceflight.
Dr. Hoffman, thanks so much for telling us all about your experience fixing the Hubble Space Telescope.
Well, it's been a pleasure. It's been fun doing this podcast. I hope everyone enjoys it.
On your next visit to the Museum of Science, take in a planetarium show and see some amazing images of the universe, many of them from Hubble. While you're home, follow the museum on social media for more of my talk with Jeff, including many of the challenges that astronauts will face when exploring Mars. Until next time, keep asking questions.